Welcome to another episode of Science to Sleep By. Tonight, whether you're settling into bed on the East Coast or winding down on the Pacific side, I invite you to slow your breath and look up, because above us, far beyond the soft glow of American city lights, an interstellar traveler has crossed our skies quietly, unexpectedly, and carrying mysteries older than our sun. This is the story of 3I Atlas, the third visitor from another star, and the silent warning it may have brought with it. The story of 3I Atlas begins not with a flash of light, not with alarms or excitement, but with something far softer, far quieter, something almost shy. An object drifting against the enormous backdrop of the cosmos, barely whispering its presence across the darkness. When astronomers first noticed it, there was no dramatic moment, no cinematic reveal, no sudden realization that an interstellar traveler had entered our solar system for the third time in human history. Instead, it was like noticing a faint ripple on an otherwise still pond, a subtle shimmer in a sea of stars, a point of light that didn't behave the way the other points of light were expected to behave, a speck whose motion traced an unfamiliar path. It was as if something ancient had wandered into our neighborhood without announcing itself, taking its time, letting the universe reveal it only when it chose to. This quiet arrival is what makes the beginning of the 3I Atlas story so captivating. The cosmos often speaks loudly, through supernova and gamma-ray bursts and violent collisions of planets and stars. But sometimes, the most meaningful messages are the ones carried by the faintest travelers. 3I Atlas was one of these. For days, maybe weeks, it drifted unnoticed, its presence masked by distance and darkness, and even when telescopes finally captured it, the signals were delicate, like strands of light stretched thin across unthinkable distances. Only after careful observation did its true nature begin to unfold. This was no ordinary comet or asteroid. It was something from far beyond the gravitational influence of our sun. It was moving too fast, too confidently, on a path that could not have originated from anywhere nearby. It was a visitor, a messenger from another star. Imagine, for a moment, the sheer distance it had crossed. Where did it begin its journey? What ancient star system launched it into the void? Was it pulled from the icy edges of a distant solar family, or blasted away by a cataclysmic event we will never witness? By the time it reached us, 3I Atlas had likely been traveling for millions of years, drifting between the stars at speeds the human body cannot comprehend. It had passed through regions of space so empty that a single atom might drift for miles before meeting another. It had endured cosmic rays, gravitational nudges, and encounters with forces strong enough to bend the trajectory of worlds. Yet through all of this, it remained intact enough for us to see, to measure, to study. And in its quiet arrival, it asked us to pay attention. When it slipped into our solar system, it did so with a kind of grace, not tumbling chaotically, not erupting with activity, but gliding a motion so smooth that scientists had to double-check their own instruments to make sure the data was real. Compared to Oumuamua, which darted past us like a glimmering shard, and compared to Borisov, which behaved more like a typical comet, 3I Atlas entered with a steadiness that was almost calming. It didn't break apart immediately, didn't flare with volatile jets, didn't turn chaotic under the sun's heat. It simply arrived. And in that arrival, it carried a feeling of familiarity wrapped in the unknown. There is something deeply peaceful about the idea of an interstellar object making its way across the sky with such gentle persistence. Here on Earth, especially in the United States, where our nights can be filled with the hum of cities, the buzz of traffic, the glow of light stretching across entire coastlines, it is easy to forget how silent the universe truly is. But 3I Atlas reminded us. It reminded us that beyond the noise of our modern world, the cosmos moves with an ancient patience. It reminded us that even streaks of rock and ice, older than our planet itself, can approach without fanfare. And it reminded us that some of the most extraordinary events in the universe begin quietly. For astronomers watching from observatories in Hawaii, California, Arizona, and across the globe, its detection was almost meditative. The faint signal rose, dipped, and rose again as it reflected sunlight. They zoomed in on their screens, adjusting their instruments, testing their filters, confirming that this faint traveler was indeed real. And as the data accumulated, it revealed something astonishing. The object was not bound to our sun. It was merely passing by, on a hyperbolic path that would never bring it back again. Each interstellar visitor is a once-in-humanity encounter, because they never return. Once they leave, they are gone forever, continuing their silent drift toward the next unknown destination. The night sky over the United States became, for a moment, a gateway. For those who knew what to look for, 3i Atlas wasn't just a point of light. It was a connection to somewhere else, a distant world or system we may never see, a piece of cosmic history older than every mountain range, every civilization, every heartbeat on Earth. And as it continued its approach, astronomers noticed something unusual. Its brightness didn't behave as expected. Its trajectory shifted in subtle, puzzling ways. Its signals were faint, but not faint enough. Clear, but not consistent. It was as if the object were teasing us, offering clues while withholding answers. This subtle strangeness was the first hint that 3i Atlas might not be a typical cosmic visitor, that it carried something unusual, something we were not fully prepared to understand. And yet, its arrival remained peaceful. No chaotic tumbling, no violent tail eruptions, no dramatic fragmentation. Just a quiet traveler drifting through our solar system, asking us to observe, to listen, to learn, to pay attention to the delicate patterns and subtle motions that reveal the deeper stories of the universe, inviting us to slow down enough to hear the whispers of an object that began its journey long before humanity took its first steps, long before the ocean settled, long before Earth became the home we know today. When 3i Atlas entered our solar system, astronomers immediately placed it beside the only two other known interstellar visitors, Oumuamua and 2i Borisov. These three objects now form a rare trio, each one carrying a different story, a different signature, a different whisper from the deep unknown. And yet, among them, 3i Atlas stands apart in ways both subtle and astonishing. Its behavior, its brightness, its motion, and its silence all combine to create a personality that feels both familiar and strange, like meeting someone who reminds you of an old friend, but speaks in an accent you cannot quite place. Oumuamua, the first interstellar object ever observed, was fast, puzzling, and elusive. It slipped past Earth with a long, flattened shape scientists struggled to explain. It tumbled in a way no ordinary asteroid should, accelerating in a manner that defied expectations. Some called it a cosmic shard, others, a light sail from another world. Despite all the theories, the truth of its identity remains a mystery, locked forever behind its fading trail. Borisov, the second interstellar visitor, was different. It behaved much more like a traditional comet, bright, active, shedding gas and dust as it warmed under the sun. It was more predictable, more familiar, like a well-behaved traveler passing through and leaving behind a trail. We knew how to read. Scientists could analyze it, compare it to comets from our own solar system, and uncover similarities and differences. That helped piece together the chemistry of other star systems. Then came 3i Atlas, and it refused to fit neatly into either category. It wasn't the wild, tumbling mystery that Oumuamua was, nor was it the clearly active comet that Borisov had been. Instead, 3i Atlas revealed itself as something in between, a hybrid of sorts, but also something completely unique. It carried hints of comet-like behavior in the way it reflected sunlight, yet it lacked the strong, reliable signs of outgassing. It moved with a steadiness that did not match a fragmenting object, yet its brightness curve suggested changes on its surface that scientists could not fully explain. One of the first things astronomers noticed was that 3i Atlas had a brightness pattern that shifted just slightly off the expected rhythm. Not wildly, not chaotically, but with a kind of soft irregularity, like the flicker of a candle shielded by a quiet breeze. This irregularity suggested either rotation, surface variation, or material release, yet none of these possibilities produced data that matched perfectly. The surface, perhaps, had patches of highly reflective ice, or maybe it carried a coating of dust unknown to our observations. Each hypothesis answered one question, but opened another. Its shape, too, remains a point of intrigue. Oumuamua was elongated like a shard, while Borisov was more rounded and comet-like. But 3I Atlas appears to sit somewhere in the middle. Not dramatically long, not perfectly spherical, but shaped in a way that causes light to scatter unevenly, creating moments of brightness followed by sudden dimming. Yet these changes are so smooth, so gentle, that they feel almost intentional, as though the object has a quiet rhythm of its own. Even its trajectory adds to the mystery. Like the other two interstellar visitors, it traveled on a hyperbolic path, proof that it came from outside our solar system and would never return. But the details of its motion puzzled scientists. Its inbound speed was modest compared to Borisov's, yet higher than Oumuamua's. Its arc through the solar system was slightly bent by gravitational interactions, but not in the ways that typical comets respond. There was no dramatic shift, no sudden flare of acceleration. Instead, the object moved as though guided by invisible hands, steady and unwavering. In the United States, where observatories from Arizona to Hawaii watched it glide across the sky, astronomers exchanged notes with a mixture of curiosity and calm urgency. There was something about 3I Atlas that seemed almost deliberately quiet, as if its behavior had been softened by its long voyage through interstellar space. Perhaps cosmic radiation had weathered its surface, smoothing out sharp edges. Perhaps dust had settled on it, muted by millions of years drifting between stars. Whatever the reason, the object radiated a kind of ancient stillness that neither Oumuamua nor Borisov possessed. Its composition remains one of the greatest puzzles. Borisov showed clear signs of carbon monoxide and other icy materials, revealing itself as a true comet with active jets. Oumuamua, on the other hand, remained frustratingly inert, showing no tail, no coma, no active regions. But 3 Atlas teases both possibilities. It reflects light in patterns that suggest icy content, yet it refuses to display the visible outgassing that ice would normally produce near the sun. Some researchers proposed exotic ices that sublimate quietly, releasing tiny bursts invisible to our telescopes. Others suggested a surface coated by interstellar dust, fine, ancient, undisturbed, and precious. What truly sets 3I Atlas apart is the feeling it creates, a sensation that it carries secrets older than our solar system. Oumuamua gave us confusion. Borisov gave us clarity. But 3I Atlas offers something more poetic. Ambiguity wrapped in calm. It feels like an object that has seen the slow drift of galaxies, the silence of interstellar clouds, the birth and death of stars. Unlike Oumuamua, it does not rush. Unlike Borisov, it does not flare. It simply moves through our region of space like a traveler passing through a quiet town at night, leaving only footprints in the fresh snow. This object reminds us that interstellar visitors can take many forms, and that the universe may be full of materials, structures, and chemical combinations we have yet to recognize. And while 3I Atlas brings questions about its shape, its brightness, its composition, its behavior, it also brings a deeper awareness of how little we truly know about the worlds beyond our sun. Each of the 3 interstellar objects has expanded our understanding in a different way. But 3I Atlas does so with a gentleness that invites reflection rather than urgency. It allows us, particularly those watching the skies from the calm of American nights, to lean back and consider the possibility that the universe speaks not just in explosions and revelations, but in soft, drifting messengers, whose presence is easy to miss unless we are quiet enough to notice, inviting us to slow our breath and listen to the subtle differences that set 3I Atlas apart from the visitors that came before it. From the moment 3 Atlas entered the observational reach of Earth's telescopes, astronomers began to notice behaviors that didn't quite follow the rules written by our own solar system's comets and asteroids. Where Borisov's tail bloomed brightly and Oumuamua carried no tail at all, 3I Atlas appeared to sit somewhere in an unusual, almost contradictory middle ground. It presented glimmers of activity, hints of shedding material, the faintest suggestion of a tail, or perhaps something shaped like one, but not in the way a conventional comet would behave. For observers in the United States, looking through the dry air over Arizona's deserts or the crisp Pacific skies at the summit of Mauna Kea, the object revealed a pattern that felt both familiar and completely foreign. The first sign of strangeness came in the form of its tail, or rather, the attempt of a tail that didn't behave like typical solar-warmed ice. Comets form tails as their frozen surfaces heat up and release dust and gas. These materials scatter sunlight and create the glowing streamers we see trailing behind them. But 3I Atlas didn't offer that spectacle. Instead, it showed something more subdued, like the faintest exhalation of dust that refused to organize into clear structures. Instead of a well-defined tail stretched out by the solar wind, its dust cloud remained oddly compressed, as if held close to the object by an unseen force or shaped by material properties unfamiliar to scientists. The coma, the halo that typically surrounds the nucleus of an active comet, was equally puzzling. It appeared inconsistent, flickering between faint brightness and near invisibility. One night it would suggest the soft glow of sublimation, and the next night it would appear almost bare. This inconsistency suggested that either the activity was intermittent, or the surface composition of 3I Atlas was uneven in ways that defied expectations. Even more unusual was the pattern of its activity. Instead of increasing steadily as it approached the sun, as most comets do, 3I Atlas sometimes dimmed, then brightened again, then dimmed once more. Its behavior formed a rhythm that did not correlate with distance, solar heating, or rotation in any predictable way. The object's core raised even deeper questions. In typical comets, the nucleus, the solid center, can be inferred by studying the surrounding dust and gas. Researchers trace how particles disperse, how jets launch, and how the coma thickens or thins. But the core of 3I Atlas seemed almost obscured, as if wrapped in a cloak of material that resisted disintegration. Instead of shedding particles freely, it released them in tiny, uneven puffs, hinting at a kind of surface cohesion or composition we have rarely seen. Some astronomers propose that the core might be covered in interstellar dust hardened by cosmic rays, creating a crust more resistant to heat than the ices of comets born in our own solar system. Such a crust could suppress outgassing, allowing only minimal activity to escape. The orientation of the faint tail added another layer of mystery. It didn't align precisely with what solar radiation pressure should have dictated. Instead, it drifted at a slight, consistent angle that could not be fully explained by standard models. This deviation raised the possibility that the dust grains themselves were different from the ones we are accustomed to, perhaps larger, perhaps unusually shaped, perhaps coated in materials that interacted with sunlight in unexpected ways. Some grains might have been metallic or carbon-rich, formed under conditions we have not observed within our solar system. Others could have been fragile aggregates, responding to light and solar wind with behavior unlike anything previously documented. More sensitive instruments revealed sporadic bursts of extremely fine dust, almost like micro-explosions, too small to be seen with the naked eye, but detectable through brightness spikes. These bursts did not correlate with temperature changes or rotational phases. The randomness suggested that the object was undergoing a slow unraveling of stresses accumulated across millions of years in interstellar space. It was as if 3I Atlas carried internal fractures or pockets of volatile material trapped beneath an ancient crust, releasing themselves in unpredictable moments. Like sighs from a traveler who had held his breath for a very long time. Even stranger was the spectral analysis. Normally, studying how an object reflects or absorbs light reveals clues about its composition, whether its surface contains water, ice, carbon compounds, silicates, or metals. But 3I Atlas produced a spectrum that was faint and incomplete, showing weak hints of certain compounds while refusing to confirm them. Some wavelengths suggested carbon-based material, while others hinted at exotic ices rarely seen outside the coldest edges of our solar system. The inconsistency made astronomers wonder whether the object had been altered by its interstellar journey, bombarded by cosmic radiation that changed its chemistry in ways that defied expectations. Its rotation contributed to the confusion. Many comets spin irregularly, wobbling or tumbling in ways that make their activity appear inconsistent. But 3 Atlas rotated incredibly slowly, far slower than most objects of similar size. This slow rotation meant that any active regions on its surface heated unevenly, causing strange asymmetries in its faint tail and uneven brightening patterns. It also raised questions about how the object survived its journey. Slow rotation is unusual for objects shaped by gravitational interactions or collisions. It suggested that 3I Atlas might have been gently drifting for ages, shaped not by violent events, but by the silent, persistent forces of interstellar space. For observers across the United States, especially those used to studying comets from deserts, mountaintops, and remote locations, the behavior of 3I Atlas felt like watching a candle flicker in a dark room where the air currents are too soft to feel. The light shifts, the movement hints, the glow pulses, but the cause remains invisible. Scientists debated whether the dust was too heavy, the ice too volatile, or the crust too strong. Every explanation answered only part of the puzzle. No single theory fully fit. This puzzling behavior brought an almost philosophical awareness. Interstellar objects are not bound by the rules we know. They carry materials shaped by the birth of other stars, by physics we have yet to witness, by conditions foreign to our familiar solar neighborhood. The faint, inconsistent tail and the mysterious core of 3I Atlas are not just scientific puzzles. They are reminders that the universe contains countless worlds, each with its own chemistry, its own history, its own logic. This object, with its muted activity and unpredictable patterns, invites us into a deeper sense of curiosity, a quiet acceptance that the cosmos often reveals itself in fragments rather than full explanations, encouraging us to slow our minds enough to contemplate what might lie beneath its gentle, flickering behavior. When 3I Atlas swept into our solar system, astronomers around the world did what they always do when faced with an object that defies easy classification. They began to theorize. In the quiet of late-night observatories, beneath the soft hum of tracking motors and the glow of monitor screens, researchers exchanged possibilities in calm, measured voices. And as with the 2 interstellar visitors before it, the theories surrounding 3I Atlas began branching into 2 broad paths: those rooted in the natural laws of physics, and those that suggested something beyond our current understanding. Yet this time, the distance between these 2 paths felt thinner, more permeable, as if the object itself refused to sit neatly in one category or the other. The most conservative theories suggested that 3I Atlas was simply a fragmented interstellar comet, a shard of ice and dust ejected from its home star system by gravitational disruption. Many comets in our own solar system form tails, shed material, and behave irregularly. So perhaps, astronomers reasoned, 3I Atlas was simply doing what old comets do, except its long voyage had altered it in ways unfamiliar to us. Exposure to cosmic rays for millions of years might have hardened its surface into an unusually tough shell. Impacts with tiny interstellar grains could have left it pitted or cracked, forming pockets of volatile ices trapped deep beneath the crust. These hidden reservoirs might release faint bursts of activity at unpredictable intervals, explaining the inconsistent flickers observed in its tail. Another natural explanation imagined 3I Atlas as a relic from the chaotic birth of an alien solar system. When young stars form, they are surrounded by disks of dust and gas that eventually coalesce into planets, moons, and small bodies. In that early turbulence, countless fragments are tossed outward, ejected into the void by gravitational encounters. 3I Atlas could be one of these exiles, a frozen survivor from a planetary nursery long gone cold. If its surface carried exotic ices or chemical signatures unfamiliar to us, that would not be unusual. After all, the ingredients available in another star system's formation might differ from our own. These materials might sublimate differently, reflect light differently, or react to solar heating in ways that mimic deliberate patterns, even though they arise solely from chemistry and physics. But even within the realm of natural theories, 3I Atlas pushed boundaries. Some researchers propose that its reflective patterns hinted at metallic compounds or crystalline structures that rarely appear on comets. Others suggested it might be coated in tar like organic residues formed over millions of years in interstellar clouds. These substances could alter the way sunlight interacts with its surface, producing brightness curves that seem purposeful. If the crust were layered ice beneath dust beneath hardened organics, the object might behave like a breathing organism, expanding and contracting in response to heat, releasing dust in rhythmic pulses rather than constant streams. Yet as these theories filled research papers and late-night discussions, other scientists began to consider the more unconventional possibilities, not because they wished to jump to dramatic conclusions, but because the behavior of 3I Atlas created gaps in the natural explanations, gaps wide enough to consider ideas that broaden the horizon of what an interstellar object could be. Some wondered whether the object could be partially hollow. A hollow structure, even if naturally formed, could create unusual rotation patterns, unusual scatterings of light, and odd responses to solar radiation. Cavities inside the object could trap heat and release it slowly, causing delayed sublimation events that appear irregular and confusing. A naturally hollow object isn't impossible. Strange shapes can form during chaotic planetary formation, and collisions in space create odd fragments. Still, the idea of a hollow interstellar body drifting across star systems evokes images that feel almost engineered, even when the intention is purely scientific. A few researchers explored even bolder hypotheses, asking whether 3I Atlas might have geometric features, flat surfaces, angular edges, or reflective planes that don't typically emerge from random natural processes. Oumuamua sparked a similar debate when its cigar-like or pancake-like shape and unexplained acceleration led some to propose that it could be a fragment of alien technology, perhaps a defunct solar sail or a piece of something long abandoned. With 3I Atlas showing its own anomalies, it was natural for those comparisons to resurface, especially among scientists willing to challenge traditional boundaries. If the universe is filled with civilizations older than ours, could fragments of their technology drift through interstellar space, occasionally passing through solar systems like silent relics of distant cultures? And if such relics exist, would they behave in ways that mimic natural objects closely enough to elude certainty? Another theory proposed that 3I Atlas might be a composite object, a piece formed from materials that originated in multiple cosmic environments. Perhaps it traveled through dense molecular clouds, collecting layers of dust like geological strata. Or maybe it passed near the outskirts of more than one star system, accumulating new ices, new compounds, new scars. Such a journey would give it a patchwork construction, each layer responding differently to heat and light. This could produce the fragmented spectral readings that puzzled astronomers, the inconsistent tail, the uneven brightness. A composite object, shaped by the cosmos like a wandering sculpture, would blur the line between natural and extraordinary, between ordinary physics and behaviors that appear almost intentional. Still, others quietly wondered whether we might be seeing effects we simply do not yet understand, forces or interactions that emerge only in interstellar objects. These travelers are exposed to conditions impossible to reproduce on Earth, cosmic rays that alter molecular structures, magnetic fields that stretch across light years, gravitational encounters so subtle they accumulate only after vast spans of time. Perhaps 3I Atlas is a messenger not of alien engineering, but of alien physics we have never witnessed up close, physics that challenges the assumptions built from studying only our own solar system. In the calm of US observatories, surrounded by quiet instruments and long, slow nights, these theories didn't feel sensational. They felt contemplative, like layers of a cosmic puzzle unfolding slowly and quietly. 3I Atlas didn't provoke alarm or fantasy. It invited deep thought, the kind that settles into the mind like a soft breeze, whether natural or something beyond natural, whether a shard of a distant world or a relic of forces we have not yet learned to measure. It reminded astronomers that every interstellar visitor is a lesson. Each one stretches the limits of what we think we know, asking us to listen carefully, to observe patiently, and to remain open to the possibility that the universe still holds forms and structures beyond our current imagination. When astronomers speak softly yet firmly about the idea that we're not ready, they are not talking about panic or fear or dramatic disaster scenarios. Instead, they are referring to a quiet truth that has lingered beneath every interstellar visitor we have encountered so far. A truth revealed by Oumuamua, reinforced by Borisov, and now underscored once again by 3I Atlas. It is the realization that humanity's ability to detect, study, and respond to objects arriving from the deep of interstellar space remains far behind where it needs to be. And as this third visitor drifted across the night sky, slipping past our telescopes with the gentle calm of a feather carried on a breeze, it reminded the scientific community that even in a world filled with advanced technology and global networks, our watchfulness over the cosmos remains incomplete. For astronomers across the United States, especially those stationed in the quiet deserts of New Mexico, the mountaintops of Hawaii, and the wide skies of California, the detection of 3I Atlas felt like déjà vu. Once again, an interstellar object had been spotted only after it was well on its way through the solar system. Once again, the moment of discovery came late in the visitor's journey, leaving limited time to gather data. And once again, the faintness of the object and the speed of its transit made it incredibly difficult to study in detail. These repeated challenges revealed a gap in our observational abilities, a gap wide enough that any object following an unusual trajectory, perhaps even one headed toward Earth, could pass unnoticed until the last possible moment. We have built observatories capable of scanning the heavens with extraordinary precision, yet these observatories were designed primarily for tracking objects born within our own solar system. Interstellar objects behave differently. They move faster, approach from unpredictable angles, and shine more faintly than the familiar comets and asteroids that reflect our sun's light in predictable ways. 3I Atlas, with its subtle brightness and gentle drift, highlighted a fact that astronomers know well but rarely express with urgency. Our detection systems are optimized for what we expect, not for what the universe unexpectedly sends our way. The truth is that if 3I Atlas had been on a collision course with Earth, we would have had precious little time to understand it, react to it, or prepare for its arrival. And that possibility is not hypothetical. Interstellar objects do not follow the gravitational patterns of our solar system. Their paths are shaped by distant stars, by forces we cannot fully map, by journeys that began before humans existed. If even one of these objects happened to cross Earth's orbit at the wrong moment, the world's warning would come far too late. And while many of these objects are likely small, icy, harmless wanderers, the possibility of a larger fragment, something dozens or hundreds of meters across, is not beyond reason. This is where the phrase, "we're not ready," gains its weight. Planetary defense systems across the world, including in the United States, are improving. We have NASA's Planetary Defense Coordination Office, telescopes scanning for near-Earth objects, simulations of potential impact events, and developing technologies for asteroid deflection. Yet all of these systems are designed around asteroids and comets formed in our own solar system. They rely on detecting patterns that repeat, orbits that can be projected, brightness curves that follow known behavior. Interstellar objects break all those expectations. They arrive unannounced, behave unpredictably, and leave before we have time to gather complete information. 3I Atlas brought this issue to the forefront once more. Its faintness, its unusual tail, its inconsistent brightness, all of these traits made it harder to track. Small variations in light can drastically affect calculations of its size, mass, and direction. A dim interstellar object might appear smaller than it truly is, causing scientists to underestimate the potential threat. An unusual rotation pattern might skew the trajectory prediction, making the object appear harmless until new data forces a sudden correction. And because these objects do not orbit the Sun, they are not part of the regular surveys designed to catalog threatening bodies. The limitations became even clearer as astronomers tried to piece together the object's composition. Without a clear understanding of what 3I Atlas is made of, it becomes impossible to predict how it would behave near Earth or under the stress of atmospheric entry. An object rich in volatile ices behaves very differently from one composed of rocky material or metallic compounds. If humanity cannot determine the composition of an interstellar visitor with confidence, it also cannot determine the correct response strategies for any that come closer than comfort allows. Beyond physical preparedness, there is also the matter of scientific readiness. Interstellar objects carry information from outside our cosmic neighborhood, potentially holding clues to chemistry, formation, processes, and materials that do not exist in our solar system. And yet, because they are fleeting, because they move quickly, because they arrive with little warning, we are rarely positioned to take full advantage of the opportunity they offer. 3I Atlas reminded researchers that our instruments, though powerful, are often deployed too slowly to catch the earliest stages of these objects' entrance. Early data is crucial. The moments when the object is still approaching, when its behavior reveals its thermal properties and outgassing potential. By the time 3 Atlas was fully detected, much of that window had already passed. In many ways, humanity's unpreparedness is not a failure, but an invitation. An invitation to expand our eyes toward the sky, to develop new technologies, to create broader surveys capable of scanning deeper and wider than ever before. It is a call to view interstellar objects not as rare oddities, but as recurring visitors that may appear more frequently than we once believed. If 3 have already passed through our solar system within just a few years, then the universe may be far more crowded with wanderers than we realized. 3I Atlas carried a message written not in words, but in its quiet crossing. The cosmos is not distant or static. It is alive with travelers, each on paths shaped by forces older than Earth. Some come peacefully, offering knowledge and wonder. Others might come with trajectories that demand caution. And while the United States and the rest of the world have begun to sharpen their gaze toward the stars, the gentle, fleeting passage of this object reminds us that we are still learning how to watch, how to protect, how to anticipate, and how to prepare for visits from beyond the familiar boundaries of our sun's embrace. 3I Atlas is not merely a visitor passing through our solar system. Its arrival is a quiet disruption, a reminder that the space between the stars is not empty, not silent, and not void of activity. For decades, interstellar space was treated as a vast cosmic desert, a place where dust, radiation, and distant starlight drifted without urgency. But with objects like Oumuamua, Borisov, and now 3I Atlas, astronomers are being pushed to reconsider what truly fills the space between star systems. This third recorded interstellar object has become a catalyst for a deeper question. What if interstellar space is not a lonely emptiness, but a pathway filled with fragments, wanderers, and relics from ancient cosmic origins? The journey of 3I Atlas began long before our sun existed. Somewhere in a distant part of the galaxy, around a star we may never identify, gravitational forces ejected this object into the enormous sea of space. Its path may have crossed near other stars, drifted through regions of thick cosmic dust, or passed by planets forming in the early stages of their development. It is a traveler whose story reaches far beyond the limitations of human history, carrying with it the chemical fingerprints of places we cannot yet imagine. By the time it reached our solar system, it had already spent millions, perhaps billions, of years wandering in isolation. As 3I Atlas glided across our telescope's view, astronomers noticed that it behaved differently from typical comets within our solar system. Its brightness fluctuated in irregular ways, hinting at surface properties shaped not by our sun, but by environments far removed from it. Its tail appeared unusually faint and inconsistent, suggesting that the material evaporating from its surface was not entirely familiar. This raised questions about what kind of ices, minerals, or compounds could have survived in the deep cold between stars, untouched by starlight for unimaginable stretches of time. The object's behavior forced scientists to consider that interstellar material might follow physical rules that are not perfectly mirrored by the comets and asteroids. In our own planetary neighborhood, interstellar space has long been described as a vacuum so empty that a cubic kilometer might contain only a handful of atoms. Yet 3I Atlas suggests that this emptiness is also filled with countless unbound objects, ice fragments, rocky shards, planetary leftovers that drift between star systems. Until recently, it was believed that such objects passing into our solar system would be rare, perhaps once every few centuries. But the detection of 3 interstellar visitors within just a few years has shattered that assumption. Instead of rare interruptions, these objects may be regular features of cosmic traffic, crossing from one stellar environment to another. If this is true, then interstellar space becomes something more like a slow-motion river, carrying debris from the birth and death of stars across vast distances. Every object like 3I Atlas could be a messenger, carrying samples of chemistry, structure, and processes we have never observed up close. Some may contain compounds that are unstable under our sun's radiation, meaning that their true nature can only be glimpsed during the short window after discovery. Others may hold within them clues to the environments in which life might form, including amino acids, complex carbon chains, or organics shaped by alien conditions. The implications extend beyond science alone. The presence of more interstellar objects than expected changes the way we think about cosmic evolution. Stars forming or dying may eject far more debris than our models currently assume. Young planetary systems may be throwing vast quantities of material into the galaxy, material that could serve as the building blocks of future worlds elsewhere. Interstellar objects might even play a role in distributing the building blocks of life across space through a process known as panspermia, where biological or pre-biological compounds hitch rides on fragments and spread from one region of the galaxy to another. The structure of the galaxy itself becomes more dynamic in light of objects like 3I Atlas. Instead of imagining the Milky Way as a set of isolated star systems loosely connected by gravity, we begin to see a network of subtle interactions, where debris, radiation, and magnetic fields weave together in ways that are constantly evolving. Interstellar objects become the physical evidence of these interactions. Their motions tell us about the gravitational pull of distant stars, about the turbulence of molecular clouds, and about the unseen currents that guide material across the galaxy. As astronomers studied 3I Atlas, they also faced unexpected difficulties. Small changes in brightness made it challenging to determine whether the object was tumbling, rotating smoothly, or shedding material unevenly. Each possibility reveals different aspects of its interior composition and thermal structure. A smooth rotation might indicate a solid body, while chaotic tumbling could point to an irregular shape or a fractured surface. Uneven outgassing might reflect unusual ices that react differently to heat than anything found in our local comets. Each interpretation pushes researchers to broaden their understanding of what interstellar objects can be. The object's faint tail was particularly intriguing. Typical comets in our solar system display bright, well-defined tails due to sunlight heating their surfaces and releasing gas and dust. But 3I Atlas released far less than expected. This raised the possibility that the object contains materials that do not sublimate easily, or that it has already lost much of its volatile content during its long journey through the cold. Alternatively, it might mean that the object's surface is coated with a layer of material hardened by cosmic radiation, a kind of shell created over millions of years that now prevents fresh interior ices from reaching the surface. Such radiation-induced crusts are rarely seen in local comets, but could be common among objects drifting through interstellar space. This realization also adjusts our understanding of cometary evolution. If interstellar space is filled with radiation strong enough to sculpt or harden the surfaces of wandering bodies, then the first interstellar visitors we have observed may only represent one type within a much wider variety. Some objects might be rich in organics, some might be metallic fragments created in the violent destruction of planets, and others could be icy bodies untouched by radiation due to their size or composition. The diversity hinted at by only 3 examples suggests that we have barely begun to understand what might drift in the dark between the stars. 3I Atlas forces us to rethink not only the composition of interstellar objects, but also the architecture of the galaxy itself. It compels scientists to consider how frequently stars exchange material. Our sun has neighbors, and those neighbors have gravitational reaches that occasionally overlap with ours. Over long timescales, the solar system moves through different regions of the galaxy, encountering pockets of higher debris density or cleaner regions shaped by large-scale galactic waves. Each interstellar object that enters our system carries a trace of these regions. Their trajectories tell stories about gravitational interactions beyond our sight. Their surfaces tell stories about chemistry shaped elsewhere. Their survival tells stories about temperature, radiation, and collisions that occurred long before Earth formed. And so 3 Atlas becomes more than a comet. It becomes a fragment of the galaxy's memory, a shard of ancient processes carried through cosmic time. In its quiet movement, it suggests that interstellar space is a place of motion, exchange, transformation, and hidden complexity. It encourages astronomers to let go of outdated assumptions and to embrace a new understanding of the universe as a place alive with traveling messengers, each one offering glimpses into regions we have yet to explore. When 3I Atlas drifted into our cosmic neighborhood, it brought with it something more profound than dust, ice, or rock. It carried a sense of perspective, a reminder that the universe is constantly in motion, constantly exchanging pieces of itself across enormous distances. Interstellar visitors like 3I Atlas are not just physical objects. They are cosmic storytellers. They arrive silently, without warning, crossing the cold gulfs between stars to reach places that were never meant to be part of their path. Conclusion: reflecting on 3I Atlas and our place in the cosmos, we follow the journey of 3I Atlas through our solar system. Its quiet passage offers lessons far beyond the scientific. Unlike the comets and asteroids familiar to our telescopes, this interstellar visitor brings with it a perspective that stretches across millions of years and countless light years of space. It reminds us that the universe is not static, that it is alive with motion, with travelers, with mysteries waiting to be discovered. From the anomalies in its brightness and tail, to the subtle inconsistencies in its rotation and composition, 3I Atlas challenges our assumptions and invites us to reconsider what we think we know about the cosmos, about matter, and about the forces that shape both. Its arrival underscores the gaps in our readiness. Despite advanced detection systems and decades of astronomical observation, humanity still finds itself observing these interstellar visitors after they have already passed most of their journey, with precious little time to study them in full detail. This is not a failure, but a call to action, to expand our observational capabilities, to refine our models of interstellar physics, and to develop a deeper understanding of the dynamic, interconnected galaxy through which we travel. 3I Atlas highlights that even in the vastness of space, where distances are measured in light years, our corner of the universe is part of a larger, intricate network of matter, energy, and history. Beyond its scientific significance, 3I Atlas carries a message of wonder and humility. It connects us to the ancient and the distant, to environments that predate Earth itself, and to processes occurring far beyond the limits of our observation. It teaches patience as we study its subtle signals, curiosity as we interpret its unique behavior, and openness as we confront possibilities that stretch beyond conventional understanding. It illustrates that knowledge is not only gained through what we immediately see, but also through reflection, imagination, and the quiet patience to observe phenomena unfolding over cosmic timescales. Ultimately, 3I Atlas is a reminder of our place in the galaxy. We are observers on a small, fragile planet, yet our capacity to detect, study, and understand these travelers is a testament to human curiosity and ingenuity. Each interstellar visitor offers a chance to learn, to expand our comprehension of planetary formation, interstellar chemistry, and the interconnected nature of the galaxy itself. Through 3i Atlas, we are reminded that the cosmos is both stranger and more generous than we often realize, offering us not only scientific puzzles, but also inspiration, wonder, and a timeless connection to the greater universe, of which we are an inseparable part. It leaves us with a sense of anticipation, knowing that other interstellar visitors will arrive in the future, each carrying their own mysteries, messages, and gifts, continuing the silent dialogue between the galaxy and those of us who take the time to watch, listen, and understand.